Welcome. Let's solve Leetcode 2349, design a number container system. Okay, let's make this slightly bigger so we can read it. Okay. Design a number container system that can do the following. Insert or replace a number at the given index in the system. Return the smallest index for the given number in the system. They want us to implement the number container class. So the number containers initializes the number container system. The method change has the signature, it accepts an index and a number, and it fills the container at index with the number. If there is already a number at the index, replace it. Then they want an additional method implemented or defined called find that returns an int that expects an int. Returns the smallest index for the given number, or -1 if there is no index that is filled by number in the system. Okay, here's example 1 here. So here's number containers, and this initializes it, and then they ask us to find the number 10, and -1 should be returned in that case because nothing has been populated beforehand. Change would be something similar to populating it or update, maybe even a combination of the both. So we defined the index 2 to have the value 10. Here the index 1 has the value 10, index 3 has 10, index 5 has 10. And then they ask us, in this case, so these are all changes. And when we get here to this 10 here, it's a find. So they want us to find 10. And remember, when it says find, they want us to return the smallest index for 10 in this case. So in this case, it would be 1, because 2, 1, 3, and 5 are the indices that are associated with the value 10, and 1 is the smallest. Here's a update, or a change, and we set the value at index 1 to 20, and then they ask us to find 10. So remember, previously 1 had the value 10. Now in this case, we changed the index 1 to 20. So now the smallest index for 10 now is 2, which is returned here. Okay, so I think the problem is straightforward. Now it's just a matter of coming up with an approach. So my recommendation is to use two, depending on the language you use, two data structures, or sorry, two in essence a data structure, a dictionary for Python. So we'll use something called maybe an index to number, and it'll be a dictionary. And then we'll use then a number to indices, and this will also be a dictionary. However, this will be a dictionary from an int to an int, but this dictionary will be a int to a list. However, this list will be a heap. We'll be using it'll be a minheap, in fact, a minheap. So we'll be using the heap queue library for this. So this will help us always return the smallest index. So again, this will help with efficiency in this respect, and when finding the minimum index for this number. Okay, so let's start off by doing that. Well, let's just maybe run through something real quick. So suppose our first task is to maybe, this is an example kind of like theirs. So suppose they want us to insert at the value index 1, maybe the value 10. So according to our setup here, for index, I'm just calling it for now index to num, it would look something like this here. Let's say at 1, 10. But while doing that here, let's maybe move this up here. Maybe it makes more sense. But while also doing that, we'll have our number to indices, and it would look something like 10, and then we'll have a list here which would hold 1. Okay. Now, suppose now our next, what do they call these? Well, when we're given one of these, I don't know what they're called, maybe like a query or a transaction. What are they called here? Doesn't really have a name, but whenever one of these methods is called change or find. So in this first example, or that I'm providing, is that this would be an update in this case, or sorry, a change. This would be a change. Now suppose we have a secondary one, that where we change 1 to maybe 11. No, that's fine. We'll change it to 20. So that means in this case, our data would change. So we would change 1 to 20. So this gets updated to 20. However, though, what we'll be doing here is that instead of deleting our numbers to index, we'll just modify it. So it'll be something like 20 goes to 1. So notice no deletion took place, because it's not really necessary, although it's maybe slightly inefficient memory-wise. It's more efficient computationally wise. So remember, we don't have to. Remember, it's not really necessary. That they don't ask us to do that. So the key data structure here, or I guess the important one, is this tells us where something is at. So at index 1, we know the value is at 20. And so that's what we know for certain, or at least where it's supposed to be. Okay. And so, and as far as we're concerned, by looking at this, 10 isn't really accessible. So it's not a big deal. So that's fine. Although it's, in essence, it's kind of like a dangling pointer, and at some point this may be a bunch of wasted memory. But as far as the requirements for this problem, it's not much of a concern. So until it's asked of us to handle or manage used keys in a more memory efficient way, we can just leave it as is. Okay, so let's kind of get started here. So for init, we'll initialize our two dictionaries here. So in fact, let's just maybe, well, let's not. So let's set this up. Maybe we'll say, we'll say maybe self dot index to number, and we'll call this self dot number to indices. Okay, and then for a change, that's the easier method, because all we need to do is simply set it. So we'll do something like self dot index to num. So here's the index, and this will be the number. So that's for this part here. But now we need to store that where this number is stored, the associated indices with that number. So let's do that. So we'll say, well, so notice what we have here. If it's already in here, we can just append it. But if it isn't here, we need to make a new one. So let's account for that. So we can say if this number in or it's not in, sorry, it's not in self.num to indices. If it's not in there, so if it isn't here, we need to create a new one. Like, so for example, if we were changing, maybe let's do, yeah, maybe 30 here. So we would try to update it, like, because if it was 10, like for example, if this was 10 and this was 4, we would basically, this would become 10, and then we'd add it here 4, and then we also maybe add it here too. We'd say add index 4 is value 10. We would have this here. Okay. But in this case, suppose it doesn't exist, then we need to create it. Although we could probably use a default dict with a list, but that's not for now. So we'll say, okay, if it's not in there, we'll add it. So we'll say self dot num to indices number equals an empty list. And then now remember, we're going to use a minheap to always find the smallest index for the given number, and just to make it more efficient. So let's do that. So we'll say okay, and we'll say heap push self.num to indices number, and we'll add that index. Okay. Okay, good. And now this will become valuable when we're performing our find. Now let's implement the find method. So remember what the find method needs to do. It needs to, they tell us find, they pass in a number, and they want us to return the smallest index. Okay, not too difficult. So let's do that. So let's first of all check if that number is in our map here, in our what is it? Our number to indices. So let's do that. So if number not in self dot number to indices, then we can just return -1, and that's stated here. If it doesn't exist, we return -1. Otherwise, we know this number, like for example, if they ask us to find 20, now it's a matter of finding the smallest index, or for this example 10, it's a matter of finding the smallest index. So remember though, earlier though, when we had 10 originally, but then we had to change and we said set 1 to 20. So we'll need to make sure that we account for that here. So what I mean by that, let me show you. So what we're going to do is we're going to say, okay, let's find let's set this list here. Let's pull that out. So we'll say, okay, we'll say this q equals self dot number to indices and that number. So we know that that exists. So remember in this case, remember initially we had 1 and 10, and then that's what came in. They said at the index 1 the value 10. Then we store so index 1 value is 10. But here we have the number 10 and the indices associated with the value 10. But then on the next one we had set the index 1 to the value 20. So we did that here. Now here the value 20 has index 1. But notice though how in our numbers to indices, notice it says that both 10 and 20 have a 1 here. Remember, because we never deleted it here. So we'll need to perform a check when we pull that out. So let's do that here. So we'll say while q, and we'll say, okay, we'll get this index here, and we'll say the first index from the queue, which is, remember, this is a min index, so, and that's what they want. They want the the smallest index. So we say, okay, if self dot index to num index, if it doesn't equal the number, then we do heap pop q. So in this case, remember, so if we're looking for example, if we were looking for 10 at this point, so let's pretend this doesn't exist for now. Let's push it down a little bit. So at this point, if we're looking for 10, so we would say, okay, yeah, 10 is our number 2 indices. So yeah, 10 exists, and we have an index 1. So what we need to do is go back over here, and then we check, is this, when I plug in 1 here, does this value equal 10? And if it doesn't, then we need to try, if there's other indices in here, we would try them. But if it doesn't, you would just stop. So we'll keep doing this. Otherwise, so if this doesn't equal that number, then we just keep popping. If it is equal, well, then we can return that index. At some point, if you exhaust all the elements within Q, then you can just return -1, because we know that that number didn't exist. So for example, going back to our initial example here, so initially we had store 10 at the index 1. We did that here, and then we did that here. So this was, it's like it's like a bidirectional storage in essence. And then when the change came, they said, okay, let's change the index 1 to the value 20. So then we did that here. So now 20 is at index 1. But we still have this old value there. And then, so what we'll do is we'll keep trying to find if any of these matches 10. And if it doesn't, we just stop. That means 10 doesn't exist in our data structure, in this number containers. And then so we just return -1. And that should be it. Let's test it. Okay, let's test it. What went wrong here? Let's see. Oh, number not in. My apologies. Okay, looks good. Let's submit it. Okay, looks very good. Now let's try to solve this in C++. Right, so let's change this really quickly here. And we'll basically be using the same approach. Okay, so let's maybe change this to description here. So we'll be using the same exact approach. So let's begin here by initializing our data structures we'll be using to store these. Okay, so we'll have, again, maybe we'll use two unordered maps. So one unordered map, we'll store the int to the int, and we'll call this index to number. Then in this case, for our second map, unordered map, we'll be storing an int, and this will be mapped to a priority queue, which will be of int, and will be stored using a vector of ints. And since we want to make this a min heap, we'll need to pass in the comparator, which will be greater and int. And we'll call this similar to the other one. We'll call this maybe number to indices. So number to indices. Now remember, I know it's somewhat counterintuitive, but the default for priority queue is going to be less, which makes it a max heap. But when you use greater, it makes it a min heap. I know it's somewhat counterintuitive, However, that's just the way it is. And now we don't need to do anything with the constructor. In fact, we can delete it. We don't really, there's a default constructor that we can just go ahead and depend upon. Okay, so now let's go to change. Okay, so change is similar. We basically just need to set it for our index to number. So let's just do that. So index to number will be index equals number. Okay, that's easy. And now let's we need to push this index into our numbers. So we'll say so number to indices, and now number is the key in this case, and then we just need to push the index. Okay, fair enough. All right, and now let's implement the find method here. Now, just by chance, I know it's a subtle difference, but do any of you happen to know the difference between a method and a function? I know it's somewhat interchangeable, but there is a difference technically. So if any of you happen to know, put it in the comment. Just I think terms like that or definitions are valuable to know. But if not, we can discuss it later, maybe in a different video. But just something, just like a little piece of trivia. In any case, let's go ahead and implement this method here. So let me just change this to n for the moment instead of number. So what we do, if they're trying to find, we're trying to find this number, we need to look through this this unordered map. So let's do it. So we'll say while so number to indices for that particular number isn't empty. So remember, this number is mapped to a priority queue, which is in essence is kind of like a vector, and we're checking if that's empty, and we don't want it to be empty, so we put a not here. So while it's not empty, and we need to check if, now we're going to go back over here, and we need to check if the number associated with this index is the same at the current index here. So it's kind of like our previous example. So we can say if number to indices n dot top. So this would be this right here is the index. Now, what we want to use now so this will have the current index to number mapping. So let's use that. So we'll say index to number, then we'll use that index there, and then we'll check if this doesn't equal that number, then we need to pop it. So we can say number to indices n dot pop. Now in C++, when you have a while loop or a for loop, you don't need to use curly braces when you only want to include a single line with the while loop. You could put it there, but I'm not going to. Next, so we'll just keep popping until either we find the number or we've run out of indices in to indices for that number. So let's check that here. So we'll say if now this is empty, that means we didn't find it. We'll say, so it's empty, that means we kept trying to pop until there's nothing left. Okay, so then if it's empty, then we just return -1. That means there's at least one element in there, so we can just return that one element remaining in this num to indices. So we'll just return the top one. So we'll say return, and that should be that. And we can do that. And I think we're done. Let's test it. Okay. My apologies. Okay, looks good. Let's submit it. All right, looks very good again. All right, cool. So again, I always try to promote, well, not always, but I encourage um, developers to be proficient in more than one language. And so this is just part of that. And Python is a good, in my opinion, a good language to know, and something like C++, a more a typed language is good to know as well. And then there are many languages to know, like maybe C++ or Rust or Go. Those are, or Java. Those are more strict languages in essence. So again, whatever language you choose to learn, I think again I just promote or encourage bilingual coders. All right, cool. If you found this video helpful or educational, please consider liking or subscribing. Other than that, have a wonderful day. Take care of yourself. Cheers.